Now we are going to see homework 4. The first question is the third one. Assuming an uncharged capacitor in figure 4.2, use Laplace transform to find an expression for the voltage across capacitor after the switch closes at t equal to 0. Find the time constant, rise time, settling time, and calculated voltage for the calculated voltage. Okay, this is the circuit. Five volts, 1 ohm, 0.3 farads. First of all, we need to convert this into S domain. So, S domain. For capacitor, we have seen it's 1 by SC. So, for 0.3 farads, it's 1 by S times of 0.3. This 10 by 3S. Now, this is 10 by 3S. Now we need to and when switch is closed and the circuit connects, and we have to convert this into S domain. It will become 5 by S. In S domain, the constant becomes constant by S. It is 5 by S, and it is 1. This 1 by SC. This 10 by 3S. 10 by 3 divided by S. 10 by 3S. Now, what they have asked is, use Laplace transform to find expression for voltage across capacitor of switch closes at t equal to 0. Find the time constant. And they have said assuming an uncharged capacitor. Uncharged capacitor means there is no charge in this capacitor. Okay. So uncharged means there is no charge here, and after that we have to apply. We have to find out the voltage across capacitor. After that, rise time, time constant, and settling time. So now, 5 by S, and this is 1 capacitor, 10 by 3S. Now voltage across capacitor we need. So we know voltage division. Vc of S equals to total voltage times its impedance by total impedance. 5 by S, 10 by 10 plus 3S. So therefore Vc of S equals to 50 by S times 10 plus 3S. You can write like this: 50 by S into, you can take 3 common out of it, S plus 10 by 3. Now it is 50 by 3 S plus 10 by 3. This is a voltage across capacitor. And what they have asked, find the expression for voltage across capacitor of the switch closed at t equal to 0. Find the time constant, rise time, settling time, and calculate voltage for the calculated voltage. So this is the S plane. Suppose in the denominator if it is s plus a, so therefore s plus a equal to 0, s is equal to minus a. In s plane it is minus a, and for this is called first order system, and this is for this time constant is 1 by a, and rise time is 2.2 by a, and settling time 4 by a. Now for this system, s plus 10 by 3, so in the place of a it is 10 by 3, so the time constant is 1 by 10 by 3, so it is 3 by 10.3. And after that rise time 2.2 by a is 10 by 3, which is get 10 by 3 0.66, and settling time 4 by a, which is 10 by 3 1.2. These are the three parameters they have asked. And I think there will be, we have to find out VC of t also, because they have asked VC of t. Assume the uncharged capacitor, use Laplace transform to find the expression for the voltage across the capacitor. Expression for the voltage is, this is the expression for voltage, but they didn't mention whether it is S domain or time domain. We just leave here. VC of S is, this is the expression for voltage, and these are the time constant 0.3 and rise time and settling time. Let us go through this problem once again. We have there is a resistor and there is a capacitor and there is a source, there is a switch. After t equal to 0, the switch will be closed and the capacitor is uncharged. So we know how to convert t domain to s domain. For capacitor it is 1 by sc, so for 0.3 farads it's 1 by s times 0.3. So 1 by 1 by 0.3 means 10 by 3s, so this is 10 by 3s, and 1, it is 5 by s. So after that we know voltage division. So voltage across this capacitor is total voltage times its impedance 10 by 3s plus total impedance 1 by 10 by 3s. So therefore VC of S is equal to 5 by S into 10 by 10 plus 3s. So I just rearranged the terms. VC of S is equal to 50 by this 5 times 10, 50 by S times 10 plus 3s, 50 by, so I took this 3 common, 3 into S times 10 by 3, so it is 50 by 3. This is the expression for VC of S. And how to find time constant, rise time and settling time. So in the denominator there is a pole. So suppose we have S plus A by S plus B, S plus C. These are called zeros and these are called poles. 0 means at s equal to minus a. Poles means 0 comma minus b comma minus c. How? For zeros, take numerator equal to 0. S plus a equal to 0. So s is equal to minus a. And for poles, denominator equals to 0. Therefore s times s plus b, s plus c equals to 0, which is equal to s equal to 0 comma minus b comma minus c. So we can plot in s plane s equal to minus a. This is a minus a, and this is minus b, and this is minus c, and this is a 0. Therefore minus a is 0. This is 0. 0 minus b minus c are poles. So here for first order system, time constant formula is 1 by a. For rise time it is 2.2 by a. For settling time 4 by a. Here a is pole of first order system. So here pole is s equal to minus 10 by 3. Pole is 10 by 3. So a is 10 by 3. Okay, so a is 10 by 3 here, and I just use the formula 10 by 3 to 1 plus 3 by 10. Yes, t is 3 by 10. A is 10 by 3. Yeah, 10 by 3. And 2 by 2 by a. 2 by 2 by a. This 2.2 by a. This is the rise time for setting time 4 by a. Let's move to the second question. 6b, d, f. Let me check that question. Yes, it's a 6 PDF. Yeah. For each of the transfer functions shown below, find the location of poles and zeros, and plot them on S-plane plot, and write an expression for the general form of step response. For inverse Laplace, state the name damping. So first question B. T of S equals to 5 by S plus 3 times S plus 6. So we just learned that zeros numerator equal to 0, for poles denominator equals to 0. Therefore for numerator there is no s term here, there is no s term, so there are no zeros. For denominator there are two s terms, so for denominator we have to look for poles. S plus 3 times s plus 6 equal to 0, so s equal to minus 3 comma minus 6. These are the poles, and we need to plot on s plane. We just need to minus 3 and minus 6, and in s plane poles represented by cross and zeros represented by 0, this symbol. Now general form of step response. There are three types of step responses are there. In s plane, if the poles like this and the poles like this and poles like this and poles like this, if the poles are real and distinct, that means suppose minus 2 and minus 5, these are real roots. There is no, suppose the roots are a plus ib, this is complex number, it is not a complex number, so it is a real roots. For real and distinct, this system is called over damped system. And here the roots are same, real and equal, so this is called critically damped system. And here the roots are suppose this is a minus a ib and this is minus ib, so roots are like a minus a plus or minus ib, so it has a real part and imaginary part. These are called under damped system. And there is no real part, only imaginary part. The poles are plus or minus ib, we can call as undamped system, there is no damping. Okay, now going back to our question. And one more thing is here, we need to use a general step response for each system. First of all, for under damped system, first look for over damped system. Over damped, and the poles are like this, real and distinct. For this, let's take the poles are lambda sigma 1 and sigma 2. For this, the step response is like some constant general form e power minus sigma 1 t k2 e power minus sigma 2 t. This is for over damped. And the damping is why it is over damped means the roots are real and distinct, real and distinct, because it has only real parts, there is no imaginary part on x-axis, that's why it is real. And distinct, distinct means different. Therefore for roots real and distinct, the system is over damped. For that, the general step response is C of t equal to k1 times, k1 is a constant here, exponential power minus sigma 1t, and k2 times exponential power minus sigma 2t. So for now, critical damped system. For critically damped means having the poles at same place, at sigma. Poles are at same place. Now for this, k1 plus k2 t times e power minus sigma 1 t. This is a general form of step response. Now for underdamped. For underdamped means roots are real and roots are complex conjugate. Complex conjugate roots. That means they are having real part and imaginary part. Real part and imaginary part. For this system, C of t equals to a into e power minus sigma t cos omega dt plus phi. And here a plus ib we call as sigma plus j omega d. Here roots will be there, right? That roots we call as sigma plus j omega d. So now going back to our question. So location of poles and zeros. There are no zeros. We located poles minus 3, minus 6 on S plane. Okay. We find out there is no zeros, and we find out that poles are S equal to minus 3 and minus 6, and we plot on S plane. After that, general form of step response. General form of step response C of t equals to, and it is a overdamped. For overdamped, it is k1 e power minus sigma 1 t, k2 e power minus sigma 2 t, and sigma 1 and sigma 2 are these, sigma 1 and sigma 2. Therefore, k1 e power minus 3t, k2 e power minus sigma 2, minus 6t, minus sigma 1 minus sigma 2. And damping is, we already know the damping is, if the roots are like this, we can say it is over damped. Okay. Now the D part. T of S equals to 20 by S square plus 6s plus 144. So same way, for zeros, numerator equals to 0, 20 equal to 0, it is not correct, so there is no S term. If there is only S term, then only 0, so no zeros. For poles, denominator equals to 0, therefore S square plus 6s plus 144 equal to 0. So for this, how to find roots of this one? S square plus 2 zeta omega n s plus omega n square equal to 0. This is a second order equation. For this, how we can find roots? These roots can be calculated as these are the how to calculate roots for second order equation. This is a formula. Now just compare these two. In the place of 2 zeta omega n we have 6. In the place of omega n square we have 144. So now just substitute here and find out the roots. So minus In the place of 2 zeta omega n, we have 6 plus or minus square root of. In the place of 2 zeta omega n whole square, it is 36, because 6 square is 36, minus 4 times of omega n square is 144 by 2. Now let's find the roots. This calculator. Uh, 36 minus 4 into 144 is minus 150. Now minus 6 plus or minus square root of minus 450 by 2. So minus 6 plus or minus, if you take out this minus, it will become j, and it is 540 by 2. So now minus 6 by 2 plus or minus j square root of 540 by 2. So by using calculator we can find 1 minute square root of 150, 140 divided by 2. It's 11.62. So these are the roots, and we got the roots for this equation: 20 by s square plus 6s plus 144. Therefore no pole, no zeros, and poles are 3 minus 3 plus or minus j 11.62. So we have to plot on S plane. Minus 3, this is the minus 3 point, and it is 11.62 j point, and it is minus 11.62 j point. Now the poles are, these are the poles. We know the poles are complex conjugate. These poles are complex conjugate. So if the poles are complex conjugate, the system is underdamped, and the general form of step response is a times e power minus sigma t. This is sigma plus j omega d plus or minus cos omega dt plus 5. Therefore a is constant, and e power minus 3t cos omega is 11 point, omega d is 11.62 t plus 5. Okay, now BDF, next F part. T of s equal to s plus 5 by s plus 10 whole square. So therefore zeros, for zeros, numerator equals to 0. Therefore s plus 5 equals to 0, s equal to minus 5. And poles, for poles, denominator equals to 0. S plus 10 whole square equal to 0. So whole square means 2 times. Therefore s equal to minus 10 comma minus 10. So we have to plot on S plane. And minus 5, this is a minus 5, and this is minus 10. This is 0. 0 represented as 0. And poles, 2 poles at the same time. This is called critically damped system. 2 poles at same place, critically damped system. And we know for this, the general form of step response C of t is k1 plus k2 times t e power minus sigma t. Sigma is 10t. This is a general form of step response. So for this problem, let's see again. Six BDF. So in this question they have asked location for poles and zeros. Find the poles and zeros and location of poles and zeros in S plane, general form of step response, and damping. So we know for zeros we need to equate numerator to 0, and for poles we need to equate denominator to 0. Therefore we took t of s equal to b part 5 by s plus 3 into s plus b s plus 6, and there is no s part, so no zeros. And in the denominator we have s plus 3 into s plus 6. We need to equate to 0 for poles. So therefore s equal to minus 3 comma minus 6. We just need to plot on s plane. This is s plane, and s equal to minus 3 and minus 6. And let's get back to this one. So therefore in control systems there are four types of systems are there. Second order system, we mostly deal with second order in control system 1. Second order system, if the roots, if the poles means use denominator and equal that denominator to 0, we can get the poles. So if the poles are real poles, that means in the x-axis, this is the x-axis and this is y-axis. If the poles are on the x-axis and distinct, that means different poles, we can call as real and distinct. If the poles are real and distinct, then the system is called overdamped system. And the step response, the general step response becomes C1 of C of t equals to K1. This is constant e power minus sigma 1 of t. This is the first pole. K2 e power minus sigma t. This is the second pole. Now, if the poles, that means if you equate denominator to 0, you get a poles. If the poles are equal, then we can say real and equal poles. Real poles because it is in the x-axis. Then the system is called critically damped system, and its step response is C of t equals to K1, which is constant, plus K2 constant, time whole bracket e power minus sigma 1 t. And after that, if the poles are in the form of A plus or minus IB, minus A plus or minus IB, that means it has a real part and imaginary part, then we call as complex conjugate poles. If the poles are complex conjugate, then the system is underdamped system, and its step response is A times, which is constant, e power minus sigma t, which is a real part, cos omega t plus d, and here A plus b IB is sigma plus j omega t. Now there is one more case. If the poles are only imaginary, there is no real part, then we call as undamped system. Now going back to our question, we have the poles are real and distinct here. Here the poles are real and distinct. So general we can call as this system is overdamped system, and the step response is, we know general form, K1 e power minus sigma 1 t, K2 e power minus sigma t. So next D part, 20 by s square plus 6s plus 144. So equate numerator to 0. Equate numerator to 0. There are no మల్సాయి చెప్పు మల్సాయి.
ఆ ప్లేస్ కాడికి వెళ్ళొచ్చామన్నారు, ఓకే అని చేసుకోమన్నారు. అది మనకేమన్నా ఒక రూమ్ ఏమన్నా బుక్ చేస్తే బాగుంటుంది ఏమన్నా.
మల్సాయి నేను క్లాస్ లో ఉన్నాను, నేను ఒక 1 hour 1.5 hour తర్వాత చేస్తాను.
సరే అన్న అయితే.
For zeros, make numerator equals to 0, therefore there is no s term, so there are no zeros. For poles, equate denominator to 0, so s square plus 6s plus 144 equal to 0, and it is in the general form of this form, s square plus 2 zeta omega ns plus omega n square equal to 0. For this the roots are minus 2 zeta omega n plus or minus square root of 2 zeta omega n square minus 4 omega n square by 2. Here 2 zeta omega n is 6 and omega n square equal to 144. Therefore you have to put here 2 zeta omega n is minus 6 plus or minus, we have to substitute all these values, and you can find the roots, and here we get minus 150. So if you take that minus 150 outside, minus sign outside, you will get g minus 6 plus or minus j square root of 540 by 2. The roots are minus 3 plus or minus j 11.62. We have to plot in the explain, minus 3 plus or minus j. So if the roots are complex conjugate, then the system is called underdamped system. under damped system, and the general form of step response is this is a e power minus sigma t cos omega t plus 5. Therefore a e power minus 3t cos 11.62 t plus 5, and the f part is t of s equal to s plus 5 by s plus 10 whole square. For zeros, equate numerator to 0. For poles, denominator equals 0. Therefore repeated poles, s plus 10 whole square means s equal to minus 10 comma minus 10. So the poles are real and equal, so we can call as a critically damped system and the general form of step response. Let's move into the 11th question. 11b def, 11 also bdf. 11. Let's find the damping ratio and natural damping ratio. Damping ratio means zeta, and natural frequency for the second order system of problem 6. Problem 6. Okay, same question. Show that the value of damping ratio confirms the type of the response. Okay, damping ratio. Okay, so before going to this question, let's see if zeta, we don't know zeta, what is zeta, but just if zeta equal to 1, the system is critically damped system. Until now we just know critical damped system means the poles of a system should be real and equal. And one more thing to determine the system is critically damped or not is zeta equal to 1. And if zeta greater than 1, it is over damped system. Until now we just know what damped system is a system in which the poles of a system are real and distinct, but we can find in using the zeta value also. If zeta greater than 1, it is over damped. And one more thing is zeta less than 1. If the zeta less than 1, we call as under damped system. And until now we know under damped system is a system in which the poles of a system are complex conjugate, and we can find damping by using this also. We just need to compare two methods. That is what he asked. And if zeta equal to 0, it is undamped, there is no damping. Okay, now same questions, I think B. So B means 6b, 5 by s plus 3 and s plus 6. So now take denominator s plus 3 times s plus 6 equals to 0. So just multiply s square plus 6s plus 3s plus 18 equals to 0. S square plus 9s plus 18 equals to 0. Now equate this to s square plus 2 zeta omega n plus omega n square equal to 0. Here omega n we call as natural frequency and zeta is called damping ratio. So if you equate these two, we get 2 zeta omega n equals to 9 and omega n square equals to 18. Therefore omega n is equal to 18 radians per second, its unit. So we got omega n. They have asked for omega n, right? That's question number 11. Damping natural frequency, this is the natural frequency, and damping ratio zeta is 9 by 2 omega n. 9 by 2 times omega n is square root of 18. Let's find out. It's 1.06, so therefore zeta is 1.06. So we got damping ratio, this is damping ratio and natural frequency, and then there's damping ratio. Show that the value of damping ratio, yeah, so damping ratio is greater than 1, so we call as over damped system. So same in 6b we found it is over damped system. Yeah, in 6b we found over damped system same way, but we found here in a different way by using the poles. But here we calculated by using the formula, by using zeta and omega and by using zeta. Now let's go to the second part. Here also d is 20 by square plus 6s plus 144. So take denominator. So s square plus 6s plus 144 equals to 0. Now equate with s square plus 2 zeta omega ns plus omega n square equals to 0. Therefore omega n square equals to 144, 2 zeta omega n equals to 6. So omega n is square root of 144, which is 12 radians per second. Therefore natural frequency 12 radians per second. Now damping ratio zeta equals to 6 by 2 omega n. 6 by 2 times omega n is 12. So 2 times, so this is 1 by 4, this is 0.25. Therefore damping ratio is 0.25, and which is less than 1, so this is called underdamped system, and we just found this in a different way. Now s plus 5 by s plus 10 whole square. Take denominator, s plus 10 whole square equals to 0. S square plus 100 plus 20s equals to 0. For s square plus 20s plus 100 equals to 0, we have to equate with s square plus 2 zeta omega ns plus omega n square equals to 0. Therefore omega n square is equal to 100, omega n is equal to 10 radians per second, and 2 zeta omega n s is 20. If you equate these two, therefore zeta equal to 20 by 2 times of omega n. So if you 10 times 10 by omega n is 10, which is 1, so zeta is 1. So if zeta is 1, it is called critically damped system. So we got the same zeta is 1 means critically damped system. Now let's move in here. In this question they ask for damping ratio and natural frequency. So how we will find this is, we take a denominator, and we find in terms of s square plus 9s plus 18. We should equate this to s square plus 2 zeta omega ns plus omega n square equal to 0, and we will find zeta and omega n. And if the zeta is 0, it is undamped, and if it is less than 1 underdamped, it is greater than 1 overdamped, and equal to 1 critically damped. Now let's move on to other question. 3 after that 6, and after that 11. Now 13a. Okay. For each of the second order system that follow, find zeta, omega n, and settling time, peak time, rise time, and percentage overshoot. Therefore a is 16 by s square plus 3s plus 16. So zeta is damping ratio, omega n is natural frequency, ts is settling time, the time at which the signal settles, tp is peak time, the time at which the response is maximum, rise time, the time at which the response is rising. Percentage overshoot means it is called overshoot. I will show you now. Suppose if the system is like this, This is the final response. After some 10 seconds it will reach this steady state. If you apply something, suppose if you switch on motor, it will steadily goes and it reaches to some fixed speed and it will stop, it will continues running there. So to reach that point it will take some time, either 10 seconds, it depends upon the machine efficiency, machine characteristics. So in that time we are analyzing that time. In the time, this is the time at which the peak occurs. Peak means maximum value. This is called peak time. The time at which it is going to rise is called rise time, and the time at which it is going to settle is called settling time. And this is the final settlement, that means the value at which it settles, c of infinite. Infinity means at, that means at time large it is like this, and this is c of tp. This is means response, this is c of t, this is c of tp. That means c at a time tp. Here also this is a settling time, c of infinity. Infinity means time is large. Now percentage overshoot is, the formula is c of tp minus c of infinity by c of infinity. This is a formula for settling time. Percentage overshoot, sorry, percentage overshoot. And one more formula for percentage overshoot is exponential power e power zeta pi by square root of 1 minus zeta square into 100. And we are going to see the formulas. There is one more time, delay time. There is somewhere here delay time, that is some percentage of final value. So delay time, rise time, peak time, settling time, percentage overshoot. These are the time domain specification for second order system. For delay time is 1 plus 0.7 zeta by omega n. Rise time is pi minus phi by omega d. Phi here, phi is cos inverse zeta. And peak time is pi by omega d. Here omega d is omega n natural frequency times 1 minus zeta square. And settling time is 4 by zeta omega n. And peak overshoot we have seen exponential power e power minus zeta pi by square root of 1 minus zeta square. So now the question is 16 by s square plus 3s plus 16. So take denominator, s square plus 3s plus 16 equals to s square plus 2 zeta omega n plus omega n square. So omega, if you equate these two, we get omega n square equal to 16 and 2 zeta omega n is equal to 3. Therefore omega n is equal to square root of 16, which is 4, and zeta is 3 by 2, omega n is 4. Now it is 3 by 8, 0.375. So we got zeta and we got wn. So they have asked for zeta omega n, we got these two. And after that ts, settling time. Settling time is 4 by zeta omega n. 4 by zeta omega n is 3 by 2. We get the value as 3 divided by 2 inverse into 4. 2.667 seconds. And after that peak time. Peak time is pi by omega d, and which is pi by omega n into square root of 1 minus zeta square. Therefore pi by omega n is 4, square root of 1 minus zeta square is 0.375 square. 1 point, which is 1.0787 seconds. After that peak time, and after that rise time. Rise time is pi minus cos inverse zeta by omega d. That means omega n into square root of 1 minus zeta square. And if you substitute cos inverse 0.375 by omega n is 4, square root of 1 minus 0.375 square, you get cos inverse 0.375. It's 0.527 seconds. After that, percentage overshoot. Percentage overshoot is exponential power minus zeta pi by square root of 1 minus zeta square. Now exponential power minus zeta 0.375 pi by square root of 1 minus 0.375 square. And how much we get? Minus 0.375 pi divided by square root of 1 minus 0.375 square. Exponential power answer. It's 0.280597 something into 100, which is 28.06%. So this is just a formula based question. We know the formulas and we just have to plug in those values, and we need to find the other values: rise time, peak time, percentage overshoot, and settling time. And the next question is a 16th one. Find the location of poles of second order system with the following specifications. So okay, percentage OS is 15% and TS is 0.5 second. So we know percentage OS is e power exponential power minus zeta pi by square root of 1 minus zeta square. Normal OS, I just removed that one. So suppose 1 by OS is exponential power zeta pi by square root of 1 minus zeta square. Just remove minus sign. If you apply ln, OS is zeta pi by square root of 1 minus. I think we don't need this derivation, which comes very lengthy. Just remove this. We just need to take the formulas. We don't need how we get those formulas. Now zeta is, if you know percentage overshoot, we can find the zeta. The formula is minus ln overshoot by square root of pi square plus ln overshoot whole square. This is a formula for damping ratio. From, if you know overshoot, we can find the damping ratio, and we know the settling time TS is 4 by zeta omega n, and from damping if you get damping ratio, we can find omega n. So the pole's location is a minus zeta omega n plus or minus j into omega n square root of 1 minus zeta square. This is a pole's location. This is a formula for pole's location. We already derived this one here. Yeah, this one. Here, see here, the same formula, but we have written in a different form, because if you take these two and these two cancel, minus zeta omega n plus or minus, and there is a 2, there is a 4, if it will come out, it would be 2, so 2 to cancel, and we left with zeta square omega square minus 4 omega square, 4 get cancel, so j into omega n square root of 1 minus zeta square. Now we know the location. just a formula. Remember this formula. This is the location for poles. So now zeta equals to minus ln overshoot is 0.15. This is a percentage, but we need a normal one, 0.15. Percentage 15 by 100, it becomes 0.15. So minus ln 0.15 square root of pi square plus ln 0.15 whole square. How much we get zeta here? 0.5. You get zeta is 0.1, 0.1516 and something. It's 0.5. Keep it 0.5. So we got zeta, and we know the settling time. Settling time is 0.5 seconds. So 0.5 equals to 4 by zeta is again 0.5 and omega n. Therefore omega n equals to 4 by 0.5 times 0.5. So it is 16. Omega n is 16. Therefore zeta is 0.5, omega n is 16. Therefore pole's location is minus zeta omega n plus or minus j into square root omega n square root of 1 minus zeta square. So zeta omega n. So 16 by 2, it becomes 8. 16 multiplied with half into j omega n is 16 square root of 1 minus zeta square is 0.5 square. Now the pole's location is 16 times minus 8 plus or minus j 13.856. This is the pole's location. Suppose if you want to plot the poles, you can just minus 8 here and 13.856 here, minus 13.856 j. This is the point and this is the point. These are the poles. And next one is part B. Okay. Second part is percentage overshoot is 8%, and they have given peak time. So from percentage overshoot we can find 0.08 what damping ratio. Therefore minus ln overshoot is 0.08 square root of pi square plus ln overshoot whole square. And how much we get for this? 0.63. After that peak time is 10 seconds. So what is the formula for peak time? Delay time, rise time, peak time. Pi by omega n into square root of 1 minus zeta square. Therefore omega n equal to pi by 10 times square root of 1 minus zeta square. Therefore omega n is, we get here minus square root of 0.63 0.4 radians per second. Therefore pole's location is zeta omega n plus or minus j omega n into square root of 1 minus zeta square. So zeta 0.63 multiplied with 0.4 plus or minus j omega n is 0.4 square root of 1 minus zeta 0.63 square. So we get 0.63 into 0.4 minus 0.252 plus or minus j 0.4 into square root of 1 minus 0.63 square, 0.31. These are the poles location. Now the third part, settling time is 1 second and peak time is 1.1 second. Settling time is 4 by zeta omega n equal to 1. Zeta omega n is equal to 4 and peak time is pi by omega n into square root of 1 minus zeta square is equal to 1.1. So now how we will find pi by, just take this inside, square root of omega n square minus omega n square zeta square equals to 1.1. We know omega n square zeta square value, so pi by 1.1 equal to square root of, move this side, omega n square minus omega n zeta square is 4 square, so omega n square minus 4 square equal to pi by 1.1 square. From this we can get omega n, how much? 4.915 radians per second. So what is zeta? Zeta is 4 by omega n, 4.915, we get zeta, and if you substitute those values in this formula, we will get roots or poles location. Let's move on to next question. (21C). Where is 21C? (21C). Okay. For each of the three step responses shown in figure, find the transfer function of the system. So the transfer function for second order system general form is omega n square by s square plus 2 zeta omega n s plus omega n square. This is a general form of second order transfer function. Okay, they have given a response and the peak is here, the peak value is 1.4 and the final value is 1, so we can get zeta here. And one more thing is here, and you can see the time at which it settles. The time at which settles is 25 seconds. So settling time is 25 seconds. We know percentage overshoot is simply overshoot is C of peak minus C of infinity by C of infinity. So C of peak value is 1.4 minus C of infinity is 1 by 1, which is 0.4. So overshoot is 0.4. So we can find zeta. Zeta is ln overshoot by square root of pi square plus ln 0.4 whole square. So we would get pi square plus ln 0.4 square inverse into minus ln 0.4. It's 0.28. Zeta is 0.28. So we get zeta, and settling time is 25 seconds, which is equal to 4 by zeta omega n. Therefore omega n is 4 by zeta into 25. 4 into 25 inverse into 4, we get 0.57 radians per second. So we got zeta and we got omega n. Now the transfer function is omega n square by 2 zeta omega ns plus, sorry, s square plus 2 zeta omega ns plus omega n square. Therefore omega n square means 0.57 square by s square plus 2 zeta omega n. Zeta is 0.28, omega n is 0.57, yes, plus omega n square 0.57 square. So now if you further simplify it, we get 0.57 square, 0.3249 by s square plus 2 zeta 0.28, 0.57. So it's 0.3192 s plus 0.3249. This is a transfer function required. So the transfer, they are in this question they have asked for the transfer function. Transfer function means omega n square by s square plus 2 zeta omega n plus omega n square. Therefore from the plot we get maximum value and then the final value. This is a maximum value and this is the final value. So from that we can calculate overshoot. If you know the overshoot, then you can find damping ratio, and the settling time is 25 seconds. We know the settling time formula, you can find omega n from there, and we know once we know zeta omega n, we can calculate the transfer function. And then next question is 29. Use Laplace transforms to solve the following state space equation y of t when the input is okay. They have given x dash is equal to, x dash means differentiation of x one time, minus 5, 0, minus 1, minus 2, minus 5, 0, minus 1, minus 2 x times plus 3, 1 u of t, and y is 1, 0 x, and they have given x of 0 is 1, 0. And it is in the form x dash equal to ax plus bu comma y equal to cx. Y, c means this one, a means this, b means this. Now we need to use the Laplace transform. Therefore x dash equal to ax plus bu of s, bu. Now apply Laplace transform. Suppose you have x of t, you will get x of s as Laplace transform, and you have dx of t by dt. In homework 1 we have seen, if it is dx of t by dt means s into x of s minus x of 0, initial condition. In that homework 1 there is no initial condition, that's why we left x of 0, but in this problem they have given initial condition, so x into x of s minus x of 0. Now apply Laplace transforms here. X dash, for x dash, that means dx by dt, it is s into x of s minus x of 0 equals to a into x of s plus b into u of s. So therefore x into x of s equals to x of 0 plus a into x of s plus b into u of s. Now x into x of s minus a into x of s equals to x of 0 plus b into u of s. Now s I minus a, I need to take common here, x of s out of these two, x of b into u of s plus x of 0, and therefore x of s equals to Si minus a whole inverse. If it goes there, it will come in denominator. So if it goes up, it becomes inverse u of s plus si minus a inverse into x of 0. Therefore, one more and this is for x of s, and we know y equal to c x. Therefore, y of s equal to c into x of s. The question what they have was what the y of t. Therefore, y of s equals to c times x of s is si minus a whole inverse into b into u of s plus si minus a whole inverse into x of 0. Therefore, y of s is equal to c si minus a whole inverse into b u of s plus c si minus a whole inverse into x of 0. We need to find this equation. You can directly write this equation, no need to derive this equation. We need to find this y of s. After that, we have to apply inverse Laplace transform to find y of t. Now, si minus a equals to s00s. Si means s00s minus a. Here, how much they have given? Minus 5, 0, minus 1, minus 2. For si minus a becomes s plus 5, s minus 1 minus s plus 5, and it is 0. 0 minus 1 plus 1, 0 minus of minus 1, it is plus 1, s plus 2. Now si minus a inverse. Inverse means 1 divided by these two multiply, s plus 5, s plus 2 minus 0 into 1, this two. After that, interchange these two, s plus 2, s plus 5, and put as it is, but put minus sign here, 0 minus 1. Now si minus a whole inverse will become 1 by s plus 5 by s plus 2, s plus 2, 0 minus 1, s plus 5. Now after that, we have to find s minus a whole inverse into b. Suppose into b, we just need to find step by step into b. If we put b here, what is the b value? I'm going to find this one first of all. After this, this b31, c10. Let us first find this one. Si minus a whole inverse into x of 0, and it is c, right? C. So we have si minus a, first of all, si minus a whole inverse into x of 0. Therefore 1 by s plus 5, s plus 2, s plus 2, 0 minus 1, s plus 5. And x of 0 is 1, 0. If you multiply, this is 2 by 2 matrix and this is 2 by 1 matrix, and we will get 2 by 1 matrix as output. 1 by s plus 5 into s plus 2, s plus 2 times 1, so this is s plus 2 plus 0 times 0, 0 into minus 1 times minus 1, 1 minus 1 plus s plus 5 times 0, so it is 0. This we get, and after that we have to multiply it with c, si minus a whole inverse into x of 0. So c is 1, 0. Minus 1. So this is 1 by 2 matrix and it is 2 by 1 matrix. We get 1 by 1. For 1 by s plus 5, s plus 2, 1 into s plus 2, and 0 into minus 1, 0. So if you take s plus 2 common, so 1 by s plus 5. So therefore one part we got s plus 5, 1 by s plus 5 here. This all we get 1 by s plus 5. And we need to find this one. To find c into si minus a whole inverse into b into u of s. First we know si minus a whole inverse, and we just do this 1 by s plus 4, 1 by s plus 5, s plus 2, and which is s plus 2 0 minus 1 s plus 5, and the matrix B is 3 1. So it's 2 by 2 matrix and 2 by 1 matrix. We get 2 by 1 matrix. So therefore 1 by s plus 5 into s plus 2. So s plus 2 times 3. So 3 into s plus 2. 0 times 0 0 plus 0. Minus 1 times 3 minus 3 plus 1 time s plus 5 s plus 5. So it will become 1 by s plus 5 into s plus 2, and 3 times s plus 2 and s plus 2 again here. Now we just need to multiply with c. And what is c? 1 0. So c times si minus a whole inverse into b is equals to 1 by s plus 5 s plus 2, and c is 1 0, 3 times of s plus 2 and s plus 2. This is 1 by 2 matrix and this is 2 by 1 matrix. So we get 1 by 1. 1 by s plus 5 s plus 2, 1 by 1 matrix, 1 into 3 times of s plus 2, 0. So we get 3 by s plus 5 here, because s plus 2 s plus 2 cancel, and it is multiplied with u of s. U of s means 1 by s. So the total one is 3 by s into s plus 5. Now the total function y of s is 3 by s into s plus 5 plus 1 by s plus 5. 1 by s plus 5. So now take 3 s into s plus 5 as common. So 3 plus s. Therefore s plus 3 by s into s plus 5. This is y of s. Now we need to apply inverse Laplace transform to get y of t. First of all, for this we need to convert this into partial fractions, means a by s, b by s plus 5. If you write the whole function in terms of like this, a by s plus into s plus 5, so s plus 3 by s into s plus 5 equals to a into s plus 5 plus b into s by s into s plus 5. Therefore s plus 3 equals to a into s plus 5 plus b into s. Suppose put s equal to 0. If you put s equal to 0, you get 3 a into 5. For a is equal to 3 by 5. Put s equal to minus 5. If you put s equal to minus 5 plus 3, it becomes minus 2, minus 5 0, b into minus 5 is equal to b equal to 2 by 5. So now we know y of s is 3 by 5 by s plus 2 by 5 by s plus 5. So inverse Laplace transform pays. Let's see. For constant, it is a by s. Laplace transform pays. Constant is s e power minus a t e power minus at 1 by s plus a. This is the Laplace transform formula. Therefore, for 1 by s, it is here a is 3 by 5, so it is 3 by 5 here, y of t plus 2 by 5 times. For 1 by s plus a, it is e power minus at, so e power a plus in the a place we have 5, so minus 5t. It is for t greater than or equal to 0. This is the y of t solution. So let's see again. They have given a state space representation. They want a response y of t by using Laplace transform. So it is in the form of x dash equal to x plus bu. They have given initial condition as well. Now apply Laplace transform. X dash means dx by dt. So s into x of s minus x of 0, because the initial condition is given, equal to a into x of s plus b into u of s. So s into x of s equal to just mathematical steps, and we get x of s as si minus a whole inverse b into u of s plus si minus whole inverse into x of 0. Now we got x of s, and y is c into s, so y of s equal to c into x of s. So y is the output here, so y of s equals c times si minus a whole inverse, so we get y of s, this one. Now I took part by part, and first of all I calculated this si minus a whole inverse. So si minus a means s0 0 s minus a minus 5 0 minus 1 minus 2. So si minus a, this one. Si minus a whole inverse is 1 by 1 divided by these two multiply, these two multiply, these two multiply minus these two multiply. So s plus 5 into s plus 2 minus times 0 into 1. And again these two interchange, s plus 2 s plus 5, and these two same but minus sign. So we get like this, and after that x of 0 multiplication. If you multiply x of 0, 1 0, therefore it is 2 by 2 matrix and it is 2 by 1 matrix. These two gets equal, so we left with 2 by 1. So let's multiply s plus 2 times 1 plus 0, so s plus 2, 1 times 1 plus s plus 5 into 0, it is 1, minus 1 here. So this is the s minus whole inverse into x of 0. Now we just multiply with c. C is 1 0, so if you multiply with c, it is 1 by 2, it is 2 by 1, so 2 cancel and it is 1 by 1. So 1 by s plus 5 into s plus 2, 1 times s plus 2 plus 0 times minus 1, so it is 1 times s plus 2, so it is 1 by s plus 5. So one part we got 1 by s plus 5. Next part, now we need to find c times s minus a whole inverse into b into u of s. So si minus whole inverse into b, b means 3 1, so it is 2 by 2 matrix and it is 2 by 1 matrix, we get 2 by 1. So 1 by s plus 5 into s plus 2, s plus 2 times 3, so 3 times s plus 2 plus 0 times 1, so it is 0, minus 1 times 3 plus s plus 5 times 1. So 1 by s plus 5 into s plus 2, it is 3 times s plus 2, so s plus 2. And after that we need to multiply with c. So we are gonna multiply these two, 1 by 2 matrix and 2 by 1 matrix, we will get 1 by 1 matrix. Therefore 1 into 3 into s plus 2 plus 0, so 3 times of s plus 2 by s plus 5 s plus 2, we will get 3 by s plus 5, and we need to multiply it with u of s. U of s means 1 by s, so 3 by s times s plus 5. Now y of s is 3 by s into s plus 5 by 1 by s plus 5. Now take LCM, s times s plus 5, 3 plus s, so s plus 3 by s into s plus 5. Now we need to find the inverse Laplace transform to get y of t. So first of all convert into partial fractions, a by s plus b by s plus 5. After that mathematical operations, we found ab values, and there are Laplace transform pairs. For a it is a by s, for e power minus at it is 1 by s plus a. So we just need these two for this problem. So for a by s means a means 3 by a, 3 by 5 plus 1 by s plus, so 2 by 5 take common here, just write left side. 1 by s plus a means 1 by s plus 5, so e power minus 5t. So this is the final response of y of t. Now let's move into the next question. 55. Given the translational mechanical system of figure 4.14, okay. Okay, this is a fundamental question. In homework 2, in homework 3, there are advanced questions. First of all, we need to learn about this fundamental question. After that, we can solve those. This is M, this is F of t, and this is X of t. This is a basic mechanical system, basic one. In homework 2, homework 3, we have seen the advanced ones. First of all, we need to analyze this one, then we can analyze those. Okay, 55. This is a basic system. For translational mechanical system of figure 4.14, k equals to 1 and f of t is unit step. Find the values of m and fv. It yields a overshoot 17%, and its settling time 10 seconds. For this, this means it is a rigid body or wall, so it doesn't move. They have connected this damping coefficient, this is a spring, and this is mass, and they have applied force to displace this one. They are using some force f of t to move this by distance x of t. Therefore, from Newton's law, force f of t equals to mass times acceleration plus damping times velocity and spring times displacement. So acceleration means d square x t by dt square, 2 times differentiation of time, displacement. Fv times velocity means one time differentiation of displacement, and k is x of t. Therefore, now apply Laplace transform. For f of t it is f of s, and for m, for 2 times it is s square x of s, f of v. For 1 time s into x of s, and it is x of t. This is x of s. Now f of s equal to, take x of s common, m s square plus fv times of s plus k. Therefore, now the transfer function is, output is displacement, input is force. Output, input. Why means we are applying force, that means it is input. We are getting out displacement, that is called output. So 1 divided by ms square plus fvs plus k. So I will put in a standard form. Take m out, s square plus fv by m s plus k by m. Now compare this with standard second order differential equation, s square plus 2 zeta omega n plus omega n square, and they have given 55. They have given overshoot is 0.17, so we can find zeta. Zeta is minus ln 0.17 divided by square root of pi square plus ln 0.17 square. We get here pi square plus ln 0.17 square, square root of 17 inverse into minus ln 0.17. It's 0.49. It's 0.49, and zeta is 0.49, and they have given one more. Settling time is 110. So which is 4 by zeta omega n is 10. So therefore omega n is 4 by 10 times zeta. So which is a 10 times into 10 inverse into 4.81. So we got zeta 0.49 and omega n 0.81, and k is 1. They have given 55, k is 1. So now we need fv and m. Therefore s square plus 2 zeta omega ns plus omega n square equals to s square plus fv by m s plus k by m. Therefore omega n square is equal to k by m. Therefore m is equal to k by omega n square. K is 1, omega n is 0.81 square. 0.81 square inverse, which is 1.5. 1.5. Therefore m is 1.5. Now we need fv. So fv by m equals to 2 zeta omega n. Therefore fv equals to 2 zeta omega n times of m. So 2 zeta is 0.4, 0.49, 0.81, 0.49, 0.81 into 1.5. So now 2 times 0.49, 0.81 into 1.5. It is 1.1907. Therefore we get fv and m. In this problem they have given a basic mechanical system. First we need to learn for this system, then only we can solve the large mechanical systems mentioned in homework 2 and homework 3. This is a basic mechanical system. For this they are applying force, and by applying force they get a displacement they want. So therefore force equals to ma, mass times acceleration, and fv times velocity, and k times displacement. Therefore f of t equals to m times acceleration means d square x of t by dt square, plus f times velocity means dx of t by dt, plus k times x of t. So apply Laplace transforms here. Therefore f of s equal to m times s square x of s fv times s into x of s plus k into x of s. Now we get the transfer function, and we just equate the transfer function with the standard function, and after that we just compare with the, we know overshoot, we can find the damping ratio zeta, and we know the settling time, we can find 4 by zeta omega n, settling time omega n. So by comparing with this we can get m and fv. This is I think it's over. Homework 4 is completed. Later we will see homework 2 and 3.